Hi friends, welcome to the Unit 6 Day 1 notes. This one's over matrix solutions of linear systems, and this says by the Gauss-Jordan triangulation method. I'm going to be really focusing on how we can use technology in this particular chapter. Specifically, you're going to be using your graphing calculator to be able to really simplify this process. Everything that we talk about in this chapter is really getting you ready for the idea of linear algebra, which is used in most courses in college if you're going to a business, math. It's kind of the gateway course to learning more about how the relationships within matrices can be used to solve many real-world problems. The biggest thing to note is, as we get into this, is that we're going to be using the technology piece more so. So in this particular unit, there's not a lot of work to show. As you're working through some of these problems, just because we're going to be relying on the technology piece. I'm going to be using the notes here kind of as a guide to help you with some example problems. But note if you have any questions or anything, please email me. I'm happy to assist. The first thing it talks about is augmented matrix. So we've seen these systems before, these systems of equations. An augmented matrix is just applying this here into a matrix form. A matrix has rows and columns. So this part here, to turn it into an augmented matrix, is we look at the coefficients going in order. So we have 1x, 3y, 2z, and then a constant of 1. I'm going to talk about this extra column here shortly. And then 2x, 1y, negative 1z, and then 2, and then 1x, 1y, 1z, and then 2. And then we put a closing bracket, and then often you will see what looks to be like a dashed line or another line going down there, and that's an augmented matrix. So we want matrices to have exactly as we did when we had systems of equations. We want to have it so that we can get that like triangular shape where we have zeros here, ones here. Even better is if we can also get a zeros here as well. So we just have ones along the diagonal, and then we're going to have a value here in this last column with constants. The same problems that we can do, the same steps that we can do in systems of equations, we can do with matrices as well. Matrices is just another way to represent it. So the biggest thing to note is that all of these steps, they're the exact same that we were using earlier. I'm not going to show you the examples that we did using the same systems because everything happens the same way. The only difference is that we don't actually include the variables. So we're not including x and y. So at this point, I would have 2, 3, 7, 3, negative 4, and negative 32. So again, the goal is to have a 1 here, and then a 0 here and here as well. That's the goal. So going through all of the steps that we did in the previous chapter, it's the exact same that we would do here. You can multiply, you can swap, you can go through add two rows and replace rows. So the difference here is that now we're going to apply the technology piece for this. So the matrix key on your calculator, if you're using a TI calculator, is the inverse. You just have to press the second key to get to that first. So when you do that, you're given with a list of all of the matrices that you have. Yours may have different numbers here. I've edited mine as I've gone through and done this. So what I want to do is I'm going to actually go, the first column is is the names of the matrices. So if I just press enter at this point, it applies this matrix out on my main screen. What I want to do is I'm going to edit the matrix, and right now it says 2 by 3. The first number in the matrix is how many rows it has. So it's always row by column. And then so there's 2 rows, 3 columns. You can see I've already typed in this particular problem. So matrix A, 2 by 3. So I'm just going to press enter here and enter here. If I needed to change the size, I could do that, press enter as well. So you notice that it says A, in matrix A down here, it says A, and then it says 1, 1. This is the name of this, so this is the row and the column. If I go over here, this is going to be 1, 2. So row 1, column 2 in matrix A. And the value here is 3. So we're going to do this for all of this entire matrix. Go ahead and substitute those values in now, if you haven't already. And then to get out of this particular part, you go second and then quit. So now we're going to go back to the main screen. At this point, what I want to do is I want to find the values that give me 1, 0, 0, 1. This is called the identity matrix. And then the values that are here that it gives me as a result, those are the solutions to this equation. So to do that, again, we're going to go into the matrix menu again. So second matrix. And then this time we're going to go to the math menu. The math menu has a lot of different things in here that we can do with matrices. I'm actually going to scroll up. And we're going to be using this one a lot. This stands for reduced row echelon form. Reduced row echelon form. And so what this does is this will tell the calculator we want it to go through those list of procedures to end up back with our solution. So I'm going to go second matrix A. I'm going to go ahead and close parentheses. It does not make a difference if you do or not. It's just telling it, hey, this is the end of what I want you to find the reduced row echelon form. And you will see that it actually gives you the value 1, 0, 0, 1. And then in that last column, gives us negative 4 and 5. And that is the solution to this equation. You could check this by graphing these two lines and seeing that it does intersect at negative 4, 5. So that's a value that we can use to solve. This is one of the ways we can use solve. There are some limitations to this. So for the homework for this course, we won't have any no solutions, coincident independent. You won't have that because you can't use this form to solve. It does work in 3x3s as well. So let's go ahead and do a 3x3 example. So first, I'm just going to get my matrix correct. So 1, 1, negative 4, 10, 2, negative 3, 1, 7, 3, negative 1, negative 1, 12. And then I'm going to go into my matrix menu, edit. This is a 3x4 matrix. So 1, 1, negative 4, 10, 2, negative 3, 1, 7, 3, negative 1, negative 1, oops, negative 1, there we go, 12. I go through and double check just to make sure I've inputted all of these correctly. Enter 12. Yep, there we go. Okay. As you saw, in making one mistake, obviously here was going to change my solution. So I can quit. All right, so now, again, going to go back in, second matrix, math, reduced row echelon form, and then matrix A. And then this gives me my solution. So this is your x, y, and z value. So x equals 3, y equals negative 1, z equals negative 2. So that's the gist of this. If you have any questions, please let me know. Have a wonderful day. Bye, friends.